Question number 20. Figure A shows a parallel plate capacitor having square plates of edge A and plate separation T. The gap between the plates is filled with a dielectric medium of dielectric constant K, which varies parallel to an edge as K equal to K0 plus alpha x, where K and alpha are constants, and x is the distance from the left end. Calculate the capacitance. Here, this is parallel plate capacitor. Here inside, there is dielectric, which varies as K equal to K0 plus alpha x. We have to find out its capacitance. So we consider a small strip at distance x from left end of width dx. And we find its area. So area of the strip is equal to, since it is a square plate, so if width is dx, length will be a, so it will be a dx. Now, capacitance of this small strip. So this small strip is, suppose DC. So DC will be equal to, here dielectric constant is K0 plus alpha x times, since capacitance is given by K times epsilon naught A divided by D. So from the same concept, in place of K, we write K0 plus alpha x times epsilon naught, and area is ADX divided by separation is D. Now, this capacitor can be divided into many strips. So that will vary from x equal to 0 to x equal to a total length, and all these strips are assumed to be connected in parallel. So equivalent capacitance can be given by C equal to, we integrate with the limits 0 to a, and then we write K0 plus alpha x times epsilon naught a dx divided by d. Now, to be integrated, so K, this will become K0x plus alpha x squared by 2 limits 0 to a times other constants epsilon naught a divided by d. So we put the value of x as a, and when we put 0, so we will get 0. So I'm not writing that. So this will become K0a plus alpha a square divided by 2 times epsilon naught a divided by d. So this can be further written as C equal to epsilon naught. From here, a can be taken common. So epsilon naught a square divided by d times K0 plus alpha x, which is our answer. Consider next question. A parallel plate capacitor of capacitance 100 microfarad is connected to a power supply of 200 volt. A dielectric slab of dielectric constant 5 is now inserted into the gap between the plates. Find the extra charge flowing through the power supply and find a change in the electrostatic energy of the electric field in the capacitor. So we can write before insertion and after insertion. So before insertion, capacitance C0 is given as 100 microfarad, and after insertion, it will become C, or we can write it C1, and this will be K times C0, and K is 5, so 5 into 100 microfarad. Now charge Q0 is equal to C0 times V, Here C0 is 100 microfarad 10 power minus 6 into voltage applied is 200. So that will be equal to 20 millicoulomb. And here, suppose this is Q1. So this is C1 times V. So C1 is 5 into 10 to the power, sorry, 5 into 10 to the power 100 into 10 to the power minus 6 into voltage 200. So this will give 100 millicoulomb. Now, extra charge. Extra charge is the difference of the two charges. So this is 100, this is 20. It means 80 millicoulomb. Now, work done will be extra charge times voltage. So extra charge is 800 into 10 to the power minus 3 into voltage is 200. So this will become 16 joule. Now, energy in absence of dielectric. So it will be initial energy. Suppose we write it U0. So it is half CV square. So here C means C0. So 1 by 2, C0 is 100 into 10 power minus 6 into voltage is 200 square. So if we simplify, it becomes 2 joule. And energy in presence of dielectric, say it is Q1. So half C1 V square. So 1 by 2, C1 is 5 times because dielectric constant is 5. So 5 times 100 into 10 power minus 6 into 200 square. So this becomes 10 joule. So increase in energy. Increase in energy. It will be difference of the two, and that would be 8 joule. And this is our answer. Thank you for watching.